last few slides that I want to cover from chapter 26. There's a lot of detailed slides from the end of last lecture on toward the end of that PowerPoint, and look at those for your interest. But I won't be going very deeply into the characteristics of the specific carriers and the active transport and the co-transport mechanisms that make urine formation work so well for us. But I want to deal today with a very important idea, and that is the urine sample and the normal information that you can extract from it. So looking at general characteristics here of normal urine, you'll notice first the pH, how variable it is. pH is ranging from 4.5 to 8. So this is a bodily fluid outside the stomach that is 4.5, but you'll notice the pH can actually go up to 8, which is something that's prohibited in plasma. 7.35 to 7.45 is our normal range. At pH 8 in our plasma, we're on the floor in convulsions or we're dead. Now, normally pH is slightly acid, reflecting its effect on secretion of hydrogen ion to control our pH balance. Specific gravity, it is measurably more dense than water because of its solute content, and it does have an osmolarity that is enhanced. Water content, 97% to 93% is its normal range in concentration, and basically between 7/10 and 2 liters a day would be a normal volume range. Color is clear yellow due to urochrome, a breakdown product that involves bile salts. And the odor varies with composition. The one thing I'm very, very aware of is that whatever gives asparagus its smell comes through directly in the urine unaltered. But other foods do affect the odor of urine. Bacterial content for a healthy person. Urine is a sterile and antimicrobial liquid. In fact, in the old days, I haven't been out there in a long time, but when you go to Death Valley, in the days when the filling stations and rest stops were few and far between, sometimes 80 miles or 100 miles to the next rest stop, there would be instances where people would break down and not be rescued. And they had an information card, what to do in that case. And one of the things they do recommend is to find a clean bottle and save your urine, because the urine from a normal, healthy person, those first few urinations after you run out of water, actually are dilute enough that you can drink it and obtain enough water hydration back that it can extend your period of survival. So in a normal person, there is no infection prospect from that activity. When we look at the values obtained from standard urinalysis, we do see a daily elimination value up here at the top, focusing on that nitrogen elimination. Urea, 21 grams of urea are removed per day, 1.8 of creatinine, 0.68 of ammonia, and 0.53 of uric acid. Now, those are all in equilibrium with one another. And you can see but 23, 24, 25 grams of nitrogen containing compounds are eliminated. Toxins from our diet are converted to a thing called hippuric acid. Urobilin is absorbed by the colon, bile breakdown product, and bilirubin contributes a small amount. That's a breakdown product of hemoglobin. Now, normal ranges here will produce good health. Anything that's out of range will produce various maladies. Typical value from urinalysis, looking at, in this case, typical nutrients, show how efficient the reabsorption step in reclaiming small molecules of nutrients. So in a day, we eliminate about 1/10 of a gram of carbohydrate. Ketone bodies are an alternate form of carbohydrate, and there's somewhat more of that eliminated. Look at the very low rate of elimination or the relatively high retention of lipids within the body, 0.21 of 1 gram per day. Very, very low concentration. This is measured in the parts per million. And finally, amino acids, more amino acids escape per day, but over a 24-hour period, this is still not very much. Nutrients are retained by the body. Ions, something that we maintain. So each one of these ions has a homeostatic range that is normally maintained in the body. And we do lose sodium and chloride at the greatest level. And this is the interesting food that we have. The only thing that's not alive that we regularly take in our diet is salt. And it shows sodium chloride's ionic contribution to our metabolism, maintaining ionic concentrations, contributing to the transmembrane potential of cells, and basically being a major contributor to the osmotic pressure that's necessary for cells to stay alive. Potassium is present in large quantities in our diet, but eliminated at lower levels than sodium and chloride. And we do have traces of calcium and magnesium that are flowing out in normal urine. Red blood cells and white blood cells, this daily elimination of red blood cells is tiny. 130,000 red blood cells is truly a trace. We do check urine analysis for the presence of blood cells, and the presence of blood cells can indicate a damage to the kidney or the urinary system. Some white blood cells, and more than the red blood cells, are eliminated, but 100 or 500 cells per milliliter is in fact a very low level. So that's where I wish to stop chapter 26. And so this will be just a very, very small recording in our